Alright, so in this lesson, we will calculate arc lengths, and sector areas using a proportion. So this one says calculate the length of the minor arc. So the minor arc is AB. So we want to know what AB is. The length, not the angle, not the central angle measure, not the arc angle measure. So it's easier to kind of show you the proportion first. So if we do this 50 degrees, and we say that that's our part, which is 50 degrees, to the whole circle, which would be 360 degrees, that ratio should be equivalent to the part, which is AB. So 50 degrees to 360 degrees should be proportional to AB, the length of AB, or arc AB. I'm just going to put AB for now, to the entire circle, the length of the entire distance around, which is called the circumference. I'm just going to put cir for now. Usually people put C, but I don't want you to get confused by ABC. All right, so we can actually get the circumference. The circumference formula is 2 pi r or pi d. I like 2 pi r. That's what I grew up with. So 2 pi radius. So 2 pi. And our radius right here is 5 centimeters. I know it doesn't indicate it, but that's supposed to be the radius. 5 centimeters. So 2 times 5 centimeters is 10 pi centimeters. Well, you know. And then we're going to approximate this. We're going to use 3.14 for pi. So you're going to get 31 and 4/10 centimeters. So we can plug this in for the circumference, and we can find out what the length of AB is. So let's do 50 over 360 degrees equals AB, which is what we want to know, over the circumference, which is approximately 31 and 4/10 centimeters. We could divide here, or we could multiply and then divide here. It kind of doesn't matter. For our sakes, I'm just going to multiply both sides by 31 and 4/10 centimeters. So you just get 31 and 4/10 centimeters times 50 degrees, all over 360 degrees. And then that'll give you AB, the length of AB. So obviously, I can't do that in my head. Maybe y'all can, but I can't right now. So 50 degrees times 31 and 4/10 centimeters equals 157. No, we could get more complicated with the units and put centimeters, degrees. But for now, let's just not complicate it that way. Equals AB. If you don't mind, I'm just gonna write it over here so I don't run out of room later. So 1570 divided by 360 is approximately, we'll put approximately 4 3/36 centimeters. I guess that one should have been too. So let me box that a little better. Alright. Here we go. Now, if you wanted to do the major arc, remember this is the minor, and this would be the major one. So instead of using this, we don't use this 98 degrees. We have to do 360 minus 98. So let's subtract 50 minus 9 is 6. So 262 degrees. So instead of doing the 98, we'll do 262. Oops. 262 degrees, which is this part. 262 degrees over 360. And we'll say that equals we're trying to find E to F this way, right? We're trying to find this. So E to F, like major arc, right? Over the entire distance. Remember, part to whole, and then we do it again. Part to whole. So part to whole with the degrees equals part to whole with the distance, with the lengths. So this is the circumference. So we need to calculate the circumference. 2 pi r, 2 pi, radius is 7 centimeters. And then you can just do the same thing as the top one. I just wanted you to make sure that sometimes it'll ask you for the minor arc, which in this case would be 98 degrees. And so it's asking for this length. And then sometimes it's asking for the major arc, which is this one right here, which would not be the 98 degrees. You would have to subtract to get that one. So, for sake of time, let's keep going. Oop. Okay, so this time we're doing area. We're going to do the area one the exact same way, except for one detail. Kind of a major, get it, detail, but you'll see it's minor in its own way. So, let's do it wants to know the minor arc, so the sector. So this would be the sector created by the minor arc. It wants to know this area right here. So we know that if we take this angle right here, this angle, 120 degrees, that ratio there should be proportional to the area of that section, so the area of AB, you know, I guess you could say like CB or whatever, this area right here, to the entire area. The question is, do we know this whole area? No. So how do we get this area? So area for circles is pi r squared. So pi, radius is 6 centimeters squared. 6 centimeters squared is 36 pi centimeters squared, and which is approximately I'm going to use 3.14 again. 3.14 times 36 is 100, approximately 113, and 400 centimeters squared. This is the area. So you'll put 113 and 400 centimeters squared, and then you could do it if you let me just show you something different in this case. If you prefer, like I prefer, to put the sector area over here, so I'm just going to label this as x now. I'm going to put x over 113.04 centimeters squared, and it should be proportional to 120 over 360. Do it the same way. Multiply, divide, or you could divide first. You'll get, in this case, 1/3, which is 0.33 repeating, and then multiply by this. It doesn't matter. Y'all know how to find x. Okay? And x is the area, this area right here. I think that's all I really need to show y'all. I think y'all are good. If y'all need another example, just let me know. Thank you.